everyone in this room has heard the term federation in some shape or form. And I think like the last 3 years, I spent a lot of time implementing federation, whatever that means. We'll come to a much better definition maybe later. In various areas like small companies, enterprises, or enterprise companies that want to sell software to the consumer space, things like that. So basically the idea of that talk is to give you like an overview of what is going on in this area, what is interesting for the consumer space, what is interesting for the enterprise space, and tell you what are the technologies that seem to win in these areas, which are like the best bet if you want to start implementing something like this. And some security concerns I just came across while looking at these protocols, and just some things to keep in mind when thinking about such technologies. So as Enno said, I'm a former ERNW employee where I'm mostly focused on breaking stuff. Then I changed gears and now I'm focusing on fixing stuff, or even better, building stuff that is kind of sane from the start. I work for a small company called ThinkTecture. I'm doing security consulting in the application space, so I'm not a network guy, I'm not a network or an operating system guy, I'm an application guy. ISO layer 7, that's where I live most of the time. As I said, the whole identity management thing, this buzzword, is what keeps me on the run the last years. And just to preempt it, I'm mostly a Windows guy, I'm mostly a .NET guy, so I'm not as cool as the Unix guys. The most important part here is really, that's my email address. If you have any questions regarding whatever topic that is somehow related to this talk at least, write me an email, and that's my blog where a lot of that stuff is also replicated in some form. Cool. So basically I want to start with what is that federated identity thing, why would I care about it, how does it work, have a little comparison between the typical usages and what I think are security considerations to keep in mind. So, what is identity? Well, I guess that there are so many definitions about that. I think the most interesting one is what you say about yourself. So think about you sign up at eBay, Google, whatever. That's basically your identity. You sign up, your name, your email address, and that's not verified. You may not even be a person, a real person at the other end of the cable. Yeah. So that is something what you say about yourself. Identity is what others say about yourself. That's usually more trusted. And technically speaking, when you authenticate to an application or a network, identity means that you can prove you are a valid directory entry. Okay? So if you can authenticate against your data, your user store, then you have an identity in that system. What is federated identity? Well, typically just the idea of taking your established identity that you established with your home realm somehow, whatever that is, like your domain or like even your local Windows account maybe, and being able to take that to another security domain. And with security domain, I don't mean necessarily AD or something like this, just another compartment where security information lives, which is separated from the compartment where you come from. Okay? And quite typically, especially in the enterprise scenarios, this is also done in single sign-on style, meaning, for example, you log on in the morning to your domain and being able to access applications that live outside of your network but not being asked again for your password. Okay? So that is basically what we are talking about. Where is it used? Basically, you can identify two spaces that are interested in these kind of protocols. I think the most important one, for us at least, is the enterprise space. So the idea is you have an application and you want that application to be accessible by external people, like your customers, like business partners. I think that the canonical example is always supply chain management, for example, things like that. And you want them to be able to talk to your application, but you don't want to maintain their accounts. their accounts should be maintained from where they come from and not at your place. Okay? You don't really care about their password, and you don't want to maintain this password too. The other direction is basically you having outsourced, externalized applications, and with the whole cloud discussion, you could fire up your application at Amazon or in Azure, or you use an external application outsourcer, like for example Salesforce in the States. Do you want that your employees have to re-authenticate every time they talk to this application? Probably not. Okay. So again, there's an interest that in the enterprise area, you have your domain logon, and you can take this logon to log into some arbitrary application living somewhere outside of your own domain. That is, or even more interesting, or a side effect of that is that companies, larger companies, start to use federation technologies to federate internally. For example, when they like bought another company, and in the best case, they have the same technology running, like AD and AD. So if the admins are brave enough, they can do a cross-trust forest, whatever thing it's called these days. Or this company may use a totally different technology. Like for example, one of the guys uses IBM Tivoli, the other guys use AD or Novel Access Manager, whatever. And then you can't simply connect these two networks together. And that's why we need protocols which are, vendor independent, which are standardized and can be used to connect these things together without, that these directory services, which are typically, kind of legacy already, and you can't change them easily, which they can't. Okay, so that is one part. This is the part I will focus on because I think it's the more relevant part, especially for the audience, but also in general. And there's the consumer space, and this is kind of easy to explain. You move around the internet, there are loads of apps you are using, and maybe you think like, why do I have to log on every time again and again and again, and why do I have to fill out every time these forms again and again and again to register? At least technically speaking, it could be easier. My observation is that typically this is more used for leisure type of applications and not for real applications which where you can earn money with. So I think one of the biggest use cases for these kind of things is like when you leave a comment on your blog, so they can show your full name next to the comment without having you to type it in, things like that. Twitter is another driver in that area, but yeah, I will talk about that more in a second. And the other interesting space here is somewhere in between is when you are building software and you want to sell that software to other people. And we have the traditional model where you sell your software and it is installed on premise on their soil, and it becomes part of the Active Directory, for example. That is one, the predominant model, maybe. Or you want to do this software plus service or software as a service type of architecture, where you have software running online and you want to be able to sell that to companies, and they should just be able to connect to that, reuse their identity they have in the corporate. And then the big problem you have is when you are in this position, do you now have to support AD and Novell and IBM natively, or do you want to have some protocol which sits on top of that and can do these things in a vendor agnostic way? So it really depends to whom you want to sell your software to, but as I said, as an ISV, you typically have to adopt to your customers, and it would be nicer if there would be one way of doing that and not 15. Okay, so this brings us to the term federated authentication. So the idea is really, how can I make cross-security domain authentication happen? And if you ever, we're interested in authentication protocols, that's a tough job. Authentication protocols itself, when you have some sort of context you live in, are already tough to implement and to design. But crossing domains, and again, never ever think of AD when I say domains, it's just basically different environments really. Then it's even harder. okay? And of course, we don't want that by replicating accounts, right? I mean, that brings us back to where we are at the moment, really, where, you know, you phone up an admin, say, hey, can you create an account for Bob? Yeah, and then Bob obviously leaves the company at some place, and nobody tells the admin to remove the account, things like that. You have dead accounts, you have all this password synchronization problems, especially when you can't control both ends of the wire, and so on and so forth. So we don't want to replicate accounts. We want to be able to move my account, my existing account, to another domain, and as easy as possible. Now these protocols, which I'll talk about in a second, have varying degrees of features, okay? So, for example, sometimes the only thing that, or the thing that would be enough is that after the authentication step, at the end, you have something like a stable identifier of the user. So when the user comes back to your application, he has the same ID, and you can use that ID to hang off, you know, personalization information and business information too. A little bit more tricky is what I mean with a stable scoped identifier, meaning, so let's say, for example, two big applications federate, or use the same federation provider. So let's say eBay and Amazon. And what you don't want is that in eBay you have the same identifier as in Amazon, right? Because that can be used to correlate information between you and the other accounts. For example, let's say eBay and Amazon join at some time, or they secretly exchange information. So the idea is here to have that the user gets an identifier that is stable, always the same, but scoped to the application he's talking to. So he will have a different ID at eBay and a different one at Amazon, but always the same for these applications. That is one of the things these protocols want to do. In the enterprise space, we typically go one step further and say, okay, we don't want, or we don't not only want an ID, we want to know who the guy is, in what department he's working, what's his telephone number, what's his email address, the cost center, these things, yeah? And we don't want to ask some sort of directory service about the information, but that should be like the outcome of the authentication step, that this information is available in the application itself. And there are a bunch of protocols out there which have exactly that purpose of establishing that kind of authentication relationship. And there are, again, I try to subdivide that into the context where they are mainly used, okay? Which doesn't mean that there are maybe some sort of, you know, blurry lines in between sometimes, but mainly in the enterprise space, we are talking about the WS star family of protocols, like WS Federation, WS Trust, WS Security in the web service world, and a thing called the SAML token. And the SAML token is basically a way how to transport this information I talked about earlier. There's also a thing called the SAML protocol, and I'll show you in a second what's the distinction between these two. In the consumer space, there's one big driver, and I guess everybody knows that it's OpenID. So OpenID is an authentication system, and a quite simple one, to be honest. And on top of that, they have support for also protecting resources using OID, your login or authorization that falls out of the authentication step. And that is basically something called OAuth, which is these days mainly driven by Google, and REP, which is like a simplification of the OAuth protocol. And again, more about that later. So the whole idea how federated authentication works is typically that a user, Bob, he first authenticates, first of all, the application that Bob wants to talk to has to establish some sort of trust with a thing called a security token service. So the idea is that Bob authenticates with a security token service, and he could authenticate using, for example, integrated Windows authentication or client certificates or his password, whatever, something that makes sense in his side of the world. Yeah? And then he, in return, gets a thing called a token. Okay? And this token is typically signed, and then he can send this token on to the application, and because of the signature, the application can find out if he trusts the token. Okay, so just putting that into more perspective, that could be like your home network, and that could be a business partner. Your admins establish trust with this token server, and that is typically done by just exchanging X509 certificates. And then I could get a token from the token service, use that token to authenticate with the application. The application verifies the signature, pulls out the information that's inside of it, and then I am logged on. Okay? Of course, step 0 is always, and all these protocols can't really help with that. Step 0 is that you have to establish trust here. Yeah? And that is typically done on paper and not, in bits and bytes. Some might ask now, how is that different to AD? Well, it is not very much different to AD. Also in AD, you have a thing called a security token service. You know what that is called in AD world? It's a domain controller. Okay? And you can also establish trust in AD world, but the fundamental difference is that in AD world, you establish trust between networks, whereas here, you typically establish trust on an application basis. Okay? So you don't have to, merge or do a cross-forest trust, whatever. It is totally sufficient and independent of AD or Tivoli, whatever, to establish trust that this application trusts tokens that come from this token service. Okay, so let's look at the enterprise space in more detail and to see how the protocols work and how they don't work sometimes. So, as I said, in the enterprise space, there are two really big players here. And one is called the SAML 2.0 protocol family. And this is basically, coming from the early days from Liberty Alliance, for example, where they had to, they specified an XML format, how they could represent identity or a user. Okay, and I'll show you in a second how this thing looks like. And they came up with a thing called a SAML token type. And around that SAML token type, they built a bunch of protocols which are mostly based on HTTP and XML, and have various so-called profiles, which makes them, on one side, browser-friendly, on the other side, friendly for things like SOAP or REST. And as you can see, these are the big players here, Sun, RSA, and IBM, and as you can maybe imagine, this is more like the thing in the Java space, okay? Because Sun is the big driver in that area. And then there are the WS star protocols and their friends, and this is driven by Microsoft, IBM, and VeriSign, and as you can imagine, in this case, this is more like the .NET way of doing things. So if you have to, make a black-white decision here, besides IBM, they just wait, I guess, which standard wins, and then hop on the right one. And again, the idea is simple. You have protocols. One is for web applications, which makes them browser-friendly, and one family is for web services, which makes them SOAP-friendly. The difference between the two really is that these guys don't mandate a special token type. They just say, you can use whatever token you want, but typically it's also the SAML token type here, okay? Both stacks rely on a bunch of other stuff like HTTP, SSL, XML encryption, signatures, the info set, these kind of things, okay? This is how a token, a SAML token looks like. Okay, you can see there's a so-called SAML assertion. It lives in a certain namespace here, and then you can basically put an arbitrary number of key value pairs in that token that describes the user. So I have a user ID here, I have a name, I have a department, I could have an email address, and so on. And these are these things that fall out or that you get in return when you authenticate with the security token service, okay? So you authenticate using, for example, Kerberos to the token service. The token service goes to AD, fetches all these values, and packages them back and sends you back as an XML token, okay? And as you can see, here's a signature that makes sure that A, the token can't be tampered with on the transit way, and B, that the receiving end knows who issued this token, okay? And this is, when you have ever looked at Kerberos, that is very, very similar to how Kerberos works. The only, or the two important distinctions here are, the Kerberos token format is fixed. So the only thing you can put into Kerberos tokens are basically the user SID and a list of domain groups that the user is member of. Here, you can put arbitrary stuff into the token, which makes it much more flexible. The second thing is that Kerberos typically relies on symmetric keys. This guy typically relies on certificate-based encryption. But that, from the idea, they are very, very similar. I used to call it Kerberos using angle brackets, more or less. Okay. So let's give you a quick rundown how this thing looks like. So this is called the WS Federation passive profile, and passive means that typically there's a passive client involved, and that is a browser. Why is this guy passive? Well, because he doesn't have that much logic on its own. But a thing that works with browsers is sending him around in the world by using HTTP redirects. So the idea is the user tries to log on to an app, which, by the way, in this part of the world is called relying party. Okay? The SAML guys call it service provider. It's basically an application. Yeah? So they want to log or get to the application. The application sees, okay, you are not authenticated yet. I will redirect you to a token service. Okay? So they do a redirect here to a login page, for example, and in the query string, they send a bunch of information that is important or relevant. First of all, they say, hey, this is a sign-in message. Could be also a sign-out message if you want to do federate sign-out. That's another part of the story, really. And they say, and by the way, I am this application here. So there's a symbolic name called a realm. And this realm is basically used by the token service to look up in this database, say, okay, this application is registered. I know the application. I know what type of token information they need. And what they also typically do is they can associate a public key with this realm that they use to encrypt the token sending back to the application. So this, that only this guy can decrypt the token. So basically now authentication is happening here. That's another quite important point for takeaway. The application itself doesn't have any authentication code anymore. Okay? All the authentication is happening now on this guy, which, potentially you have a lot of them, streamlines the whole problem of, having security-related code floating around in your network quite a bit, because you can concentrate and isolate the dangerous stuff on this server. Okay, so basically now authentication has succeeded, and what happens is basically this server here posts back a form, and inside of that form there's an input named wresult, and the SAML assertion I just showed you is the form value of this post. Okay? And then, given your browser supports JavaScript, they do it automatically for you. Otherwise, there's a button saying, like, post back the token. Okay? Make sense so far? Absolutely. Okay, cool. And then the last step is this thing flows back to the application. Then you have some sort of SAML-aware toolkit sitting there, which extracts the token from the form, verifies the signature, makes sure there's an existing trust relationship with that server, and then turns that thing into some technology-specific representation of identity, which in the .NET world would be, for example, the iPrinciple interface. But that's just an implementation detail. Cool. Let me quickly show you that. I have written a token service that you can download if you're interested, which outlines the necessary steps in code that are necessary. So basically what I'm doing here is I'm triggering the redirect to the token service. This might, here we are. So this, as you can see, this is a different URL. It's even sitting on the internet here. And then all the authentication logic is now behind that web form. Okay? So, and as you can see, this guy implements passwords and client certificates, and the application itself doesn't have to. They don't care really. And then I can say, okay, let's use client certificates. And now I'm back on my local machine here. Oh no, that's the also the online one. And basically, what has happened is that the application has opened the SAML token, verified the signature, and pulled out all the information the token service has put in there, and I just showed it on the screen here. So that's the idea, okay? It's all based on redirects, and yeah, that's how it works. Now, there are some things to keep in mind here, okay? So technically, this is all good and fine. Of course, the whole thing has to happen over SSL. I'm pretty sure I don't have to specifically mention that, yeah? But of course, you are sending around information, and there's one special thing here in the browser world, is that the browser is not capable of doing some sort of heavy crypto, which basically means the server sends you back this XML token, which may be encrypted or not, but whoever has this token, either because he's like the legitimate user, or because he's eavesdropping, or because he has a Trojan running on your client, whoever has this token can authenticate, right? If I own this token, I can authenticate. So transport protection becomes an issue here. Hopefully it is always, yeah, but here it's definitely an issue. And also, the applications should implement their own replay attack, meaning every token has a lifetime and an ID, which is a GUID. And what the application should implement, and what typical toolkits do, is they look at the lifetime and cache the user the token ID for the lifetime of the token. And then if the token should arrive twice at the application, it is rejected. Okay? This is something you have to do if you would like to implement it yourself. Yeah? Important point, really. And of course, as I said, this must really go over SSL, otherwise it doesn't really make sense. Okay? In the web service world, things are a little bit different. We have much more intelligent clients, at least from the API perspective. And the idea is really simple, but this time we are not trying to talk to a web service and this guy sends us back, but typically the client knows up front where his token service is. So he talks first to the token service. This is using the WS Trust specification, which specifies the data exchange here between these two guys. And he sends something called the request security token package. And again, there's like an identifier of the application the token is for. Yeah? And because we have much more possibilities here, we can also say, and by the way, that's the certificate of the application. And this way, the token service can also authenticate the identity of the receiving end, and then pull out his privately stored public key and use it to encrypt the token. And what comes back from this request here is, again, an XML SOAP package. And this time, the SAML assertion is embedded in the SOAP response. So same idea, just different protocols under the covers. And then the client forwards the token using the SOAP security header. Okay, same idea. And this may look terribly complex, but once it's set up, it's quite simple. I'm not sure how many people are writing code in this room, but I think even if you're not, this is kind of simple code. You create a proxy to your SOAP service. Then I set credentials, and these are not the credentials for my service. These are the credentials for my token service, right? Because this guy is in charge of authentication. Then I open the proxy, and then I make a call, and that's it. And basically, I'm just returning the claims or the information in the token back to the console to prove that we really made a round trip from the client to the token service and back to the service. And because my IIS was sleeping, this may take a minute. Hopefully not a minute, but yeah, here we are. And these are the same pieces of information that you just see in the browser, now in the SOAP world, really. And here, because the client is more capable and has more APIs, we can make things much more secure. So this is very, very similar to how Kerberos service tickets work. So the idea is really, when you request a token, first of all, the WS Trust mandates that you encrypt the token. There's no way around that, otherwise you would have to quite manually turn down all kinds of security controls that are in the protocol. So basically what they do is you are making that request and you give the server 1/2 of a key, okay? That is called client entropy. And the service, the token service generates the other half of that key, and that key together is used to generate a session key, and this session key will be embedded in the SAML token, okay? This SAML token is encrypted for the recipient of the token. You get the same copy of that session key in your response message. So basically now you have that session key, and the same session key is in the ticket. And for those who looked at Kerberos, this is very similar. Now you use that session key to sign the message which goes to the application, which basically means if you can sign the message using a session key which is part of that encrypted package, then you can prove that you were the requester of that token in the first place, okay? That is called proof of possession. And this is, there are legal situations where you have to do such things. I have a customer, they do, make software for lawyers, for example, and they need proof of possession of tokens when they make the transition between the lawyer company and, for example, their data center, okay? So this is technically much more secure, but as we know, like, web services and web applications are like 80-20%, I think, of the use cases these days. But you know, just to be aware that this gives you better security by default. Whereas with web applications, we have this thing called bearer tokens, which basically mean you have the token, you can authenticate, and the only thing you can do there is really to keep token lifetimes short and make sure that you're using a fully protected end-to-end transport between all the parties. Okay. Now, what is a common scenario for these technologies? As I said, you're having like your company here with your employees, and you're having partners, customers, and so on. And when you want to make cross-domain federation work, what is typically done is that you have a token service, or often called like the identity provider, because this is the guy that establishes the identity in the form of the SAML token. And the company you're talking to has a federation gateway, and these two guys have a trust relationship with each other. And trust in this case technically, again, means that he can validate the signature of the token coming in the system. So when Bob, I'm pretty sure it's Bob, yeah, even if he has no name here, wants to talk to the application, he first authenticates with his local identity provider token service, gets back a token. This token is signed by him and encrypted for the gateway, okay? And then he forwards the token to the gateway. Because they have a trust relationship, they can now check the signature, and he gets back a new token from the gateway, which is signed by him and encrypted for him, okay? And now in the last step, he can forward the token to the application. And because these two guys have a trust relationship now, he can log on without having to maintain any sort of user account of this guy on that side of the world. Okay? And this is basically how it is really done by a lot of companies these days. What's the good thing here? Well, if Bob leaves the company, what would happen in the old world, or better, what should happen or what did not happen in the old world of federation? Nobody ever called the other guy and said, hey, Bob left the company or Bob left the building. Yeah? So you may end up with a dead account here. If in this scenario Bob leaves the building, it is much higher, the potential is much higher that they delete Bob on their side of the world, like they disable the AD account, for example. Yeah? If Bob can't authenticate with this guy, he can't get a token, so he can't authenticate here, and can't get a token and can't authenticate here. Okay, so it's almost automatic, like the whole trust chain gets stopped automatically just by disabling Bob's account in his own domain. Okay, and this is basically, as I said, a very common scenario these days. Okay, cool. And now, where this application physically lives is almost like, doesn't matter anymore. It could be on premise of this application, of this company here. It could be in the cloud. It could be wherever, as long as this application can validate an X509 signature, it's good to go. Okay? And this is much, much more lightweight than establishing trust at the AD level here. Okay? One typical issue you'll run in when you establish such an architecture is basically, so let's say you are this company here, okay? And you have trust relationship with these guys, but you also have more trust relationship with other, partners and so on. So now when he comes to your login site here, how do they know where you came from in the first place? Okay? So this is called home realm discovery, and that's just something you have to think about. So for example, if you log into the Microsoft partner website, they say, okay, you can log in, but you have to tell me, are you a partner with an external account? Are you a Microsoft employee with the Kerberos login, or are you a Live ID user? Okay? And then you have to click one of these 3 links, and they send you to either Live ID, to their internal, sign-in site for AD, or to their partners' sign-in site. The problem here is that you might not want that your customers can see with whom you have federation relationships, right? So this might not be the best way of doing it. Yeah. In that case, it doesn't matter really. So what you have to think about is, especially when you're thinking about multi-tenant applications and these kind of things, is that you have some sort of URL design where you give out that URL to your partner, and when he tries to access your application using that URL, you know to which sign-in site to redirect him here. Okay, things like that. I've just seen going wrong in the past, that you have to think about this beforehand. Okay. So this is how it works. Here are a bunch of products that you can use to implement this thing. There's the Microsoft Active Directory Federation Services 2.0, which is currently in its release candidate stage, to be released in the next 4 weeks, I think. This is basically a thing which plugs into AD and is able to issue tokens for your AD users. Okay, so if your users have an AD account, they can talk to this thing and get back a token. And from that point on, they can use the token in any shape or form, as I just showed you. Okay, so this is the Microsoft's way of projecting their corporate identities into the federated world. Okay, and of course, the same thing happens on the IBM side. There's the Tivoli Federation Manager, same idea, but they plug into whatever they call their federation service. Yeah? I guess it starts with Tivoli. Yeah? Then there's Sun OpenSSO. Of course, that's Sun's answer to the question. They use their protocol stack, the SAML 2.0 protocol stack. And by the way, Microsoft's product here, ADFS, can translate between WS star and SAML. So that's a good thing to for interop. And there's CA and Novell too. And there are toolkits which you would use at the applications which want to consume these kind of tokens. And the most typical one, at least in my world, is the .NET incarnation. There's a Java one, there's a PHP one. There are many more, really. But these are the 3 big players here. Any questions on that before I move to the consumer side of things, really? Or should we do QA at the end? As you wish. Okay. So this is the area which I don't work that much, actually, but it's still kind of important or interesting to know how it works. And that's the consumer space. And of course, this is like the Web 2.0, whatever version we are on, or Service Pack even, kind of world, eBay, Flickr, these things where it seems to be very, very important that you have only one logon. Yeah. OpenID is really like the most popular way of doing federation in this open world. It has a large backing in community. It is based on easy-to-use protocols, HTTP, redirects, query strings, these kind of things. But it's also a little bit of limited, especially by design. And I'll show you in a second what I mean with that. And there's OAuth, which is basically an API to grant access to resources. I'll show you, or I'll give you a sample in a second that makes it much easier. But this is kind of what the OpenID world looks like. Typically, many companies started being just a normal website, like Google. And then they introduced like a log-on. And I think Google's first log-on was Gmail, the Gmail account, okay? Then they had more services like analytics and Google Docs and so on and so forth. And they needed a way to share that account across their products. And of course, that's Federation, right? So they use something which is easy to use and makes sense for them, and they chose OpenID. So if you have a Google account, you already have an OpenID account, okay? If you have one of the other guys here, you already have an OpenID account. And the idea is that really everyone can become an OpenID provider, okay? If that really makes sense, I'm not sure, but that's the way it is, okay? So the OpenID website says they have 1 billion active accounts and approximately 50,000 enabled websites. That's what the OpenID guys say, so maybe cut it by half, but it's still a lot, yeah, of adoption here. So how does this work? OpenID, well, it is a little bit different. The mindset is different. With WS Federation and SAML and so on, typically always step 0 was that you somehow establish trust, okay? So if you recall my slides, the first step was always that the application trusts the provider. And that is like a manual out-of-band step you do first, okay? And that in turn means that the provider also knows about the application, okay? So there's a tighter one-to-one relationship between providers and applications, and that makes total sense in the enterprise space because they typically know each other, okay? With OpenID, it's different. By design, every application can accept every OpenID from any OpenID provider. And if you can become your own OpenID provider, you have to ask yourself, how trusted are these OpenIDs, okay? So the first step in OpenID world is not establishing trust with the provider. The first step in OpenID world is that you provide something like this, an OpenID logon, and then they have come up with a name scheme, which typically means user account dot OpenID provider. Okay, so in my case, my user account is least privilege, and the provider is myopenid.com. Okay, so now they have the spec that describes that, how they turn this into a server name. Okay, so basically they cut the first part, do www, add HTTPS to it, and then they talk to this server. Okay, and the root web page of that server must have a special link in his HTML head element, which tells him where's the login page. Okay, so many ways to interfere with that stuff. And then they do a Diffie-Hellman key exchange to have a shared key which they can use later on to sign the messages going back and forth between these two guys here. There's a fundamental difference here too. With the WS Federation protocol types, all the redirects were done via the browser, which means that the token service must only be available via or from the browser, meaning you could have an intranet token service which talks to a public website, right? Here, as you can see, the application must be able to make a direct connection to the token service, which means that they must be available on the internet. Okay? Again, this is just a side effect of how the OpenID system was designed, like being an open provider for credentials for, the Web 2.0 community. Okay, so now he knows where the login page is because he queried a guy, and then sends a GET request to this login page. As you can see, here's my ID. Here's the Diffie-Hellman key or at least a derived version of that, that can be used to sign the request. Then there are optional values they want to know about me from that server, and where should we return to when we are done with the authentication. That's how it works, okay? And then when I authenticate and all that stuff worked, then they again form another GET request, going back to the application. They know where to go to from here. And here you can basically see, here again is the HMAC SHA-256, a key. There's a nonce introduced here. And here is information about the user, basically things that were requested here. Okay? That is basically how the OpenID handshake works. Yeah? No. The only trust that you could do is to say, do I trust this part of the name, right? So you could basically lock it down to, I only want to accept, But by design, this is not what OpenID was meant to be, right? It's basically like the plurality of providers and consumers, really. Yeah. So I can show you that too. Basically, what I've written, and again, this is maybe something which is interesting to the other guy, is an OpenID to WS Federation bridge. So basically, what I'm doing here now is I'm typing in my OpenID name. So that's least privilege, myopenid.com. And now basically this negotiation happens under the covers, and I'm redirected to the OpenID sign-in page. And you can see there. Some of them, like my OpenID, they do quite a good job. For example, they allow you to associate client certificates with your account, for example, so you don't have the password hassle anymore. And funnily, there used to be a picture of me where it now says your personal icon, and that was again for preventing phishing attacks. So that basically when they create OpenID fakes and your icon is missing, this should be a phishing attack. So given that I'm at NOS conference, I maybe shouldn't type in my password now, yeah? Well, whatever. This account is, anyways, not very important. I never trust any environment, as I learned at some point. Maybe it was you who told me that, yeah? Okay, and now the whole thing goes back to my application, and here's the information that OpenID knows about me. Okay, there's another provider. There are many providers in effect. Yeah. So basically, another one which seems to be quite popular these days is VeriSign Labs. Not sure what I make out of an authentication provider which has the name Beta in his product, as you can see. But they are at least using extended validation certificates. Yeah? So it's the Beta version of the personal identity portal. Yeah? So yeah, as I said, the focus is different. I guess the focus is primarily that there's less friction when moving to typical web applications where you don't really can get harmed in a big way, at least. Yeah. So the last piece of information, just that you have heard of that, and I'm not going into detail, is the so-called simple delegation scenario. So, for example, in the States, what is very typical in the States is called valet parking. So valet parking is basically you drive in front of a restaurant and you give them the key to your car and say, yeah, have fun. Okay? So you can see the problem here, right? You're giving some arbitrary guy a key to your car. Okay? So what they introduced in the States, interestingly, is a valid key. So basically, that's a special key where you can only drive 2 kilometers with that car and the trunk is locked. Okay? So think of OAuth or simple delegation as kind of a valid parking key for the internet. So, and funnily, if you look at the official specification of that protocol, the example is, so let's say you want to print some Flickr photos. Okay, and you want to give that printing company access to your Flickr photos. Do you want to give them the password to your Flickr account? Obviously not. So that is basically how the original spec starts introducing the problem. Okay, so that basically shows in which area we are working. So the idea is this: you log on, you authenticate, you get a so-called delegation token. Think of this token as your valid parking key. Okay? This token is scoped to certain resources, aka certain Flickr pictures, and is time-bombed, meaning you have 1 day and then the token expires. Okay? You pass the token on to the printing company, and the printing company uses the token to access your pictures and prints them and sends them to you. Okay? That is the OAuth protocol family, just in case you have heard it and never knew what it's about. Okay? But that's as much as I'll go into detail here. So, just to round it up from the consumer side, where can OpenID be used, or where is it supported? Well, there are all kinds of things, as you can see. .NET, Java, PHP, Ruby, Perl, Google, of course, has support for that in their app engine. As I said, the primary driver of these things today is Google. So they are really interested in that, and Facebook. Yeah. So, which brings me to the last part. I think we have like 5 minutes or something. That's enough. What are the problems here? So, I think we have to look at these problems from 2 ways. One is like the psychological problem, and one is the technical problems here. And I kind of thought I get more laughs out of that, yeah. So if you know Facebook, then maybe you don't want to tell everyone that you bought this Orgasmo 8500, especially not your employers and your family members, but that's another story. So basically, in the last weeks preparing for this talk, I spoke to normal people, yeah, like normal users of computers, and I said, "Are you using this OpenID stuff?" And nobody said what, and they all said, "What's OpenID?" Okay, or why would I use that? Okay, and I think there's one problem here, that these protocols, in theory, are secure enough. But who understands these protocols, okay? I mean, we have so many things in the news, this breach and that problem, and I think typical users, typical non-technically versed users, they rather say, I'd like to keep my own identity and a single account for every page I'm going to, and I have a little, text file where my passwords are in, okay? So that's their view of the world, and I think that's totally valid, okay? Again, this is all about trust. Yeah? In the enterprise space, the story is different, okay? In the enterprise space, you don't have a choice, right? I mean, your identity is owned by your company, okay? And your company makes a decision with whom you make trust relationships, and I think that's fine. So typically, they already have interest in things like minimal disclosure and so on, and typically, they also have interest in tight trust relationships. So, as I said, the whole psychological thing only exists, in my opinion, in the user space, and as I said, I think that's a valid concern. Technical issues I see with these protocols, well, first of all, they are complex, as you've seen. They are not like a single GET request and you are in. I wouldn't recommend trying to implement it yourself, okay? So you should go with a proven vendor that you trust, again, yeah, and use a library that implements these things, yeah? The next problem I see is, of course, now that a user has a single account which gives him access to many applications, this single account becomes much more attractive for, attackers, right? And there's the site Fish Tank, maybe you know that, which basically monitors phishing sites. And just the last 3 days, I looked for some of them, and they are still online. So we have the Facebook login page here. Yeah. We have Gmail, and they didn't even, pick like funny domain names. Yeah, it's just a page which looks like Gmail. Yeah, or one of the biggest federation providers, or maybe the biggest of all of them, this guy. Okay, so if your account gets stolen for one of these sites, you are typically in big trouble. Okay, especially since Microsoft makes this unfortunate marriage of having Live ID to log on to blogs and managing your corporate Windows licenses, for example, yeah, MSDN accounts and these things, yeah, which you know, which brings it back to the point that sometimes it also makes sense to separate identity. Yeah. Okay, so phishing is a much more attractive attack in this world. Cross-site request forgery is a much more attractive attack in this world because now you get transparent access to many sites, and if you can trick someone into, you know, making GET requests or POST requests without being stopped by some login screen in between, you maybe are more efficient in doing your attack. The other thing, in my case, the biggest concern I see is that in the typical application space, we are talking web applications, not web services. And with web applications, the browser is the driver of the protocol, right? So we're making redirects, HTTPS, all these things, and you know that browsers give users a choice if they want to accept the site or not. So all known and unknown attacks against browsers are totally in place. There's this nice tool called SSL strip, where you basically just strip off the SSL from the wire, which brings back to the point that you should additionally encrypt the tokens and not just rely on SSL doing the job for you. And the last word I have here is that in the web services world, we don't have these problems, luckily, because web services don't have these screens like, do you want to continue regardless if the SSL certificate is, you know, fishy somehow. Yeah. So I think to wrap it up, in the enterprise space, this is tremendously powerful, tremendously useful, and I guess I don't know any big company who hasn't thought about it yet. Maybe they didn't use the word federation for it, yeah, but somehow they have to share accounts. Yeah. In the consumer space, I don't really care that much. I see OpenID having a certain value. The implementation is a little bit, well, simplistic in my opinion, and I think you just should give it a try. If you have any questions like protocols, how they work, or other concerns, I'm here for, I think, the whole day. Otherwise, write me an email, and I think enjoy your lunch. The question was if Azure will drive these protocols. Well, Azure is a platform. You can do SAML on that, you can do WS whatever, you can do OpenID. I don't see why Azure itself should, you know, drive protocols in that case. It's much like asking, will Amazon EC2 drive the protocols? It's a platform. But one... Yeah. Well, I mean, one point I haven't talked about specifically is that the whole cloud thing, federation is an enabler for the cloud. Because if you think about it, if you have all these services sitting out there in the old world, you would have to log on separately in each one of them, right? Every time. So yes, for making a successful cloud service, you need federation. Either because you don't want that your employees have to type in the password every time, or you don't want that your customers type in the password every time, because that's also a selling point, right? I'm saying, hey, we can reuse your accounts. One example is hosted Exchange at Microsoft. Yeah, so you can make a deal with Microsoft that you host Exchange in Azure, more or less, not yet, but soon, and that you can use your local domain account to talk to your Exchange mailbox. And of course, that's a big selling point for me, because I don't want to type in the password every time. Yeah, I'm already logged on. Yeah, so coming back to your question, I think Azure or EC2 or App Engine will be drivers for some sort of federation, but which protocol they will use, it's up to them. Given that Azure might have mostly Microsoft customers, then yes, they will use WS Federation and WS Trust for that. But there's no technical limitation of doing something else. You can run Tomcat on Azure. Yeah, I mean, there's no reason why I wouldn't. Absolutely. Yeah, I know them. No. I mean, yes. As I said, any sort of cloud strategy will involve federation, because you have to somehow connect these applications. Yeah. Well, at my customer base, it is really. That may be the reason, because ADFS version 1 was like very early in the game. If you look at the specs and standards today, it's only like 2 or 3 years until they stabilized, right? The industry can now say we have WS Federation and we have the SAML 1.1 token type. These are the things which seem to work now. Okay, and now I see a huge run on these technologies. Well, just the ones I just talked about, yeah? Well, of course, yeah. And then they bring in guys like you or guys like me, and we talk about that, yeah. Technically, these protocols are fine, yeah. Just keep in mind that typically it's the browser that is involved, so the browser is a problem, yeah. But the protocols themselves are fine, and they are just based on proven things like signatures, encryption, tokens. So that is no new technology. But yeah, I mean, you're right. Companies are starting thinking about it, at least thinking about it in practice. Yeah, but I think you will see a huge attraction to these things.